The last important element that is as of now completely missing from our gameplay are the enemies. And that is what we are going to implement now. By adding one type of enemy to our game together, we will begin in the asset catalog, where I will add a new folder, which I will call enemies. And inside of this new folder, I will add a new sprite atlas by right-clicking and selecting it. I can delete the existing sprite from the new atlas, and instead I want to add two images from our resource folder to the atlas. The two images that we need are these two called Orange 1 and Orange 2. So let's drag and drop them into the sprite catalog like so. To be able to easily use our animation helper method, I will just call my sprite atlas orange so that we can use this string in our code later. To add the enemies in our game, we will create a new class in our project, which will be pretty similar to our existing block class. Just like the blocks, our enemies can have a type. For us, this will only have orange to begin with, but implementing it this way will make our game easily extendable. And then the class itself is going to contain all the properties and functionality needed for the enemies. Therefore, in the custom nodes group, I'll create a file, and it will be a Cocoa Touch class and a subclass of SK Sprite Node, of course. I will call my new class enemy and then create it. Before implementing the file, I will, as always, need to import SpriteKit so that we don't get any errors. Alright, we can now start working on our enemy class, as well as the enemy file. But since this is pretty similar and uses a lot of the same concepts like our block class, I would really encourage you that you maybe pause this video and try to implement our enemies by yourself. You will need this class enemy in combination with an enumeration enemy type, just like we did for the blocks in the block.swift file. And as soon as we have our enemy class and the enumeration ready, we can then, in the SKS file, just like we added the blocks, add our enemies to the levels. These will of course again be placeholders that should just get an appropriate name, so we can then in our game scene look for these nodes and replace them with actual enemy nodes. So if you like, give it a go. If not, don't worry about it. We'll now implement it together step by step. We'll start in the new enemy.swift file, where I will, before implementing the class, add the enumeration enemy type right above it. It will once more get raw values of the type string, and then I will add the cases, which as of now will only be one single case, called orange. We only have these images for the enemies as of now, and for demonstration purposes, we'll keep it that way. As soon as I have this enumeration, I can work on my enemy class, which will get three properties. One is obviously a constant type of the type enemy type, just like in block. Our variable health of type integer, also the same way that we had it in the block class. And finally, we will add a property that is specific to the enemy class, and it will be called animation frames as constant SK texture array. You probably have guessed it. We will use this array to animate our enemies later on. Now that I have my three properties defined, I'll need an initializer for the class, which will get a parameter of the type enemy type, and I can then begin my initializer by just setting self.type to the pass parameter, just like we did in the block class. I then want to directly initialize the animation frames property by setting it to animation helper.load textures. I now want to load the textures from the SK Texture Atlas, with the name type.rawValue, which will give us orange for this raw value, and that is exactly what we just called our texture atlas in the assets catalog. I then need to specify the name of the textures in the atlas, which will just be type.rawValue again. So pretty much the same call we made for setting the frames array for the bird class earlier in the course. Finally, I will, just as we did it in the block class, add a switch statement for type to be able to set the health property of the enemy node depending on its value. As of now, we only have one type, so let's add the case orange, in which I will set health to, let's say, 100. I can delete the default case since we don't need it. Now I'm going to quickly add the required initializer to make this error disappear, and I can then continue initializing the enemy. We do need to call the superclass initializer with the parameters texture, color, and size. We do not need a color, since we want to set a texture for the sprite. Size will also be set later on, like we did for the blocks from within our game scene, but we do need a texture to pass here. I can initialize this texture right above by creating a constant called texture as a skTexture with an image name, which will be type.rawValue with an appended 1. We do have our image called orange1 here in our media library, and that is the texture that I want to initialize the enemy with. The raw value will just be orange, so we need to append the 1 to the string. I can then just pass this texture to the superclass initializer. So for the color, let's say UIColor.clear. And for the size, CGSize.0. Like I said, we will adjust the size in the game scene later on. And this concludes the initializer for the enemy node. But I do want to add some further functionality to the class by adding 3 custom methods. I do want to have the same methods that I had in my block class. One for creating the physics body and one to handle actual impact on our enemy node. So when we hit it with our bird in the game. I'll begin my method impact with a parameter force of type integer. This method will not be exactly the same as in block though, since I will also want to return a bool value this time. Inside of the method, however, it will look pretty similar. I'll start by subtracting the force from our health property using a compound operator. Then I will check if health is less than 1, which would mean our enemy is destroyed and we should remove it. So we call remove from parent to do exactly that. In this case, I will also add return true to my method. If the enemy still has some health left, so below this if statement, I will return false. Why did we do that? Well, if I now call this method on enemies from within my game scene, I can easily use this return value to check whether or not we've destroyed this enemy, and then react accordingly in the game. Why that is important will become clear when we return to the game scene soon. But before we can do that, I will continue here by implementing the create physics body method. Just like in block, this method will not get any parameters or return values, since it should just add a physics body to my node. We can do so by setting the physics body property to a new skPhysicsBody instance, which will be, once again, initialized with a rectangle of size, and then we need to pass the size property of my enemy node. After that, I want to set the isDynamic property of my physics body to true, so we can impact it with our bird nodes. Before I'm then able to set a category bit mask for my physics body, I will need the appropriate constant in my physics category struct. So let's jump over to the configuration file where we as of now only have the constants for edge, bird, and block. So I'll add another one called enemy, which will be a UN32 with the value 0x1, bit shifted to the left by 3. Now that we have this last category, we can directly go back to the enemy class and there set physicsBody.categoryBitMask is physicsCategory.enemy. I can then specify what I want to contact, test, and collide with, and that is physicsBody.contactTestBitMask, which is set to physicsCategory.all, and physicsBody.collisionBitMask, which is set to physicsCategory.all as well, so that we check any contact and collide with any other physics body in our scene with the enemy nodes. What's missing is one method of the enemy class. This doesn't exist in the block class. And this is a method with the name animateEnemy. Without parameters, which is what I want to use to continuously animate our enemies in the game. We can already tell from the two images that this animation will only be a little up and down motion of the enemy, but still this will make them look a little less static in the game. I already have my frames array in place, so I can just call run and add a skaction.repeatForever, and then an skaction.animate, where I will again choose the method with frames, time per frame, resize, and restore parameters. For the frames, I will pass my property animation frames. The time per frame will be 0.3 to not make this too quick. And for resize, I will say false, since we don't want to resize any frames here. Restore can be true, but it doesn't really matter for an infinitely running action. But it doesn't hurt us if we say true neither. And I now want to call this animateEnemy method as soon as our enemy is initialized. So I'll add the call to animateEnemy as the last line of our initializer here. Alright, and this concludes the enemy class, and we can go back to the game scene SKS file, where we can add placeholders for our enemies that we can then replace with actual enemies in the game scene class.